Let's talk about the difference between sequential logic and combinational logic. Everything we've been doing in this course so far has been called combinational logic. It means there is a combination of inputs that happens and immediately the output will change. So let's say you have something that will, you want a light to turn on if two buttons are pressed. So um, you as soon as you press one button, the output is the light is off. You press the other button, the light is off. But if you press both buttons at once, the light immediately turns on. So the output depends entirely on the input conditions. Makes sense because that's all the logic we've learned so far. Now, sequential logic means that there is a memory element. It means that the output does not just depend on the inputs changing from high to low. The output depends on the inputs changing from high to low and the previous state of that output. So, in some cases, you press two buttons and it will, the light will turn on. But in other cases, if you already have a memory element stored, it could stay off. So an example I gave you in the notes is an alarm system. In our combinational logic circuits, if you broke a circuit and triggered an alarm, then the alarm would instantly turn on. And then when you close the circuit, stop triggering the alarm's going to turn off because it depends entirely just on the value of the inputs and outputs. However, sequential logic means that it depends on the previous value of the output, what's going to happen. So in a sequential logic circuit, we can make a logic circuit where when the alarm is triggered, so let's say you open a door, open a latch, open a circuit, that circuit ends up being cut and it's not attached to power anymore, therefore it's giving a signal of low, 0 volts, then an alarm will turn on. You want this sequential logic, you want it to say that, hey, if I now close that door and connect the circuit again and it has a signal of high, I want that alarm to still keep going. You don't want to be alarmed when somebody opens the door and then have that person kind of come into the house, close the door, and then the alarm stops. You want the alarm to continue until you press something else to reset that alarm. So in this case, an alarm would trigger because a value got sent to low, a contact opened. And then when that contact closes again, that output needs to still stay high because it had already been high previously when the door opened. So it has that memory element. It says, hey, I remember that this alarm is on, so I'm going to keep this alarm even though the door closed. That's useful. That's useful in this situation, and it's useful in many situations. That alarm needs to keep going until you do something different, like, for example, press a reset button. So that's a practical example of a circuit that, yes, sometimes it will change the output, and sometimes it will not. It depends on the state of the output when the input changed. So that's the difference between combinational logic and sequential logic. Now, most digital systems need to work with sequential logic. So, of course, your cell phones, computer systems, any advanced digital system works on sequential logic. Of course, it matters the state of the logic, beforehand in time. Combinational logic is quite simple, and but it does exist. Some e-stop buttons in manufacturing. A lot of the processes or the logic that makes equipment work in systems is combinational logic, where the outputs just depend on the inputs and don't have a memory element. So that's the difference between combinational and sequential logic systems.